All right, guys, on this second example of the day, you're going to notice one big difference if you're looking closely, and that is, as I said earlier, we have a number in front of our x squared. We have a value for a now, not just a 1 anymore. Well, your natural instinct should kick in because this is a trinomial, this is a quadratic, and if we have a number out front, what we've been doing in the past was we would GCF it out of everything. But there's a problem. 3 doesn't go into 11. And that's okay, because remember, we're just trying to go to vertex form here anyways. We're trying to get it to where we can see the vertex at the end, not the zeros like factored form. So let's carry on like normal and see where we go. We're going to add 11 to both sides. That's going to cancel. We get y plus 11 equals 3x squared plus 24x. Now, normally here, we would sit there and do our b over 2 quantity squared, and we would get a perfect square trinomial. But I'm going to let you know right now, that's not going to work anymore. That's not going to work because this 3 is going to keep us from being able to use our shortcut when we're factoring. We really want that to be a 1. So we sit there and say, okay, well, how can we make it a 1? Well, we could divide everything by 3, sure, but that's going to make our left side super, super messy if we divide everything by 3. So instead, let's just factor out a 3 on the right-hand side and leave it over there. Let's just make it look a little different. So y plus 11 on the left. On the right-hand side, we're going to take the 3 out front. So then when we do that, we're going to set up parentheses for our new binomial. If we took the 3, if we divided the 3 away from this 3x squared term, we'd have just x squared. And if we divide a 3 away from this 24x term, when we divide 3 away, we have 8x, because 24 divided by 3 is 8. Now, let's double check this. I closed it off, okay? Let's look and make sure we didn't break any math rules. Let's see if it would go backwards. If we multiply that 3 in, we get 3x squared, like we want, and 24x, like we want. So we really didn't break any math rules, and in fact, we didn't do a whole lot of changing things around. It just looks different now. Well, here we can get a trinomial to pop up inside these parentheses by adding a blank in there. So we have y plus 11 on the left-hand side plus some blank equals 3x squared plus 8x plus some blank. And now you can see inside this parentheses, we're right back where we were on the last examples because we have a 1 out front of our x squared term, which means we can create a perfect square trinomial. Again, the formula to figure that out is b over 2 quantity squared. That would be 8 over 2 squared, which is 4 squared, which is 16. So we're going to add a 16 to the right-hand side. Now, here's the big step, guys. Here's where you got to focus up. Here's where you have to pay attention. It's about to get really confusing. We're not going to add a 16 to the left side because that's actually not the amount of value or the amount of weight that we put on the right-hand side. An analogy I like to use here, and this goes better if you've ever been in a weightlifting class or anything like that, is we didn't add 16 pounds to the right-hand side. Let's think of this 16 as 16 pounds. We didn't add 16 pounds to the right-hand side. We added 3 16-pound weights to the right-hand side because that 3 distributes into everything inside the parentheses. We added 3 16s on the right-hand side, okay? So to compensate, to balance out our bar, to balance out our scale, we have to add the same amount of weight to the left-hand side, okay? Well, 3 times 16 is 48, so we actually need to add 48 to the left-hand side. I know, it's tricky, but think about in terms of what that 3 does. That 3 distributes into everything. So if it were to distribute to that 16, we've actually added a value of 48 to the right-hand side, even though it didn't pop up like that. It looks different. All right, go with it, work on it. It's going to take some time to get used to. Let's continue working through this problem though. On the left-hand side, just like we have been, we're going to combine like terms here. Change to different color entirely. We're going to have y plus 59 equals 3 still out front, but we can factor this trinomial inside. We'd be looking for factors of 16x squared. We kind of looked at this already, except for this one's going to be positive. that can combine to be 8x. This time that's going to be a positive 4x and positive 4x. Okay. Which shortcuts into x plus 4 and x plus 4. So on the right-hand side, we're going to have x plus 4 quantity squared. Again, if you're ever unsure if you factored right or factored correctly, remember you can always go backwards. If we distribute this out, we get x squared. This would be a 4x and a 4x, making 8x, and a 16, and you'll see we're right back to the trinomial we were supposed to be at. Okay, so we did factor correctly. That's just a little quick check if you want to use that. And we're on to our final step here. So you can see we're almost in factored form. We just have to move this now 59 back over. We get y equals 3x plus 4 quantity squared minus 59. This would be our vertex form. And to find the vertex itself, that step stays the same. We're going to flip this one to make it negative 4. We're going to keep this one to make negative 59. Wow, really far down on that vertex, but that's okay. We tracked the math. We made sure it was right. And again, if you want to be more specific than just calling this a vertex, we know from both vertex form with a 3 out front and standard form with a positive 3 out front that this parabola also opens upwards, meaning it has a minimum there.